Okay, what's up guys? This is GodCubing with another 4C recognition video. This one's going to be about non-cycle cases. I prefer to refer to them as 2x2 cycle cases because you have two edges swapping and then another two edges swapping, and that's exactly how we solve them. First I'm going to just cover how we solve them, and then I'm going to go into some cancellations, and then I'm going to talk about how you can cancel and recognize them when you have misoriented centers. Like this. So, let's get into it. For this first case here, I call this dot on F. Very simple. We just swap these two edges. Now they're two solved, but we need to swap these two, and we need to realign everything. So we do an M2 and a U2. You can think of these not as algorithms, but I find them quite intuitive. We have these two edges that need to swap, and these two edges, same as this one, except for this is an M2 away. So we swap these two, we do an M2 to bring the other two up, we swap those two, and then we have an M2 at the end. This one, we're swapping them on the front and the back. Some people would do this, except for that is a rotation, and that's not very good in speed solving. So what you should probably do is M prime to set it up to a dot case, and then you're going to have to do an M prime at the end. So if that doesn't make sense, you do an M prime, and then you have these two and these two. So we swap those two, bring the other two up, swap those two, and then realign. This is the same as that one, but from an M2 away, as you can see. For this one, I would recommend starting with an M, because you're going to have to do an M prime at the beginning or an M prime at the end. And I find that M primes at the end of solves are a little bit more likely for you to miss them and then get a DNF. So I would recommend starting with an M, and then you swap these two, M2, U2, and now we end with an M prime. So it's a little bit more consistent. This is a dots case. It's very obvious. It all looks like dots. These ones are all, by the way, very easy to recognize. You really should not have trouble recognizing these, whereas 3 cycles, which are a little more difficult, as I covered in my other video. With this dots case, we generally regrip a little bit, and then do E2, M, E2, or E2, M prime, E2, M. What this is doing is solving two cent, because the way you can see this is instead of an edge swap, it's a center swap, so these two centers and these two centers. However, you can look at it as an edge swap, like these two edges and these two edges. So I'll show you that solution as well. So we swap the two centers, but now we're going to have to realign this with another double move, and we bring the other centers here, and then solve them, and then we just finish. I would recommend starting with an M move, because that way you end with an M prime, and as I said, that's more consistent. I'll show you the other solution as well. So we have an opposite swap of edges. This edge needs to go here, and this edge needs to go here. Same over here. So what you can actually do is U2, and then you have these two edges swapping, because see how this edge was swapped, or this edge with this one, and this with this one? When we do a U2, now they're right here. So it's the same as this case, which we had before, basically, but just a U2 away. Yeah, we did a U2 to set up to it. So then we do a M, U2, M2, U2, M, U2, M2. We had to do the U2, M2 because that's how we were offset from that. So that's a longer solution, but if you really struggle with the E2M solution and finger tricking it, by the way, there's a video from Key and Mansour on how to execute that. I'll link it if you'd like. For this one, you can do a center swap, E2, M prime, E2, and then do another M prime to align the middle slice. However, this one you can also do the edge swap thing, so U2, M, E2, M2, E2, M. Yeah. As you can see here, with all these cases, the edges that are the same color are always going to be opposite. As you can see, with all of them. And that's how we can tell that it's not a cycle case and it's a 2x2 case. Sorry about that. Okay. So that's helpful. And then when we do this, we can glance to either side. It doesn't really matter. We insert them, and then we see from here that it's a dot case, right? It looks like a dot case, doesn't it? Or a boat. You could say it looks like a boat because this is opposite from all the others, not this one. So it's very obvious that we could do a normal AUF, but then we do a U2. So that's the same as just doing a U. And then that allows us to cancel M2, U2. For this next one, the same thing applies, except for instead of this one being opposite, this one's opposite all of them. So it looks like a table, if you want to look at it that way. And then we see that we would normally AUF to align the corners with a U prime. However, then we would have to do a U2 to start the algorithm, or solution. So that's the same as just doing a U move. M2, U2, M2. Here we have this case, and you can't cancel into this case, so you're just going to have to suck it up. This one, also you can't cancel. This is the dot case, you'll see that. You just can't cancel into it. This is a dots case, and you can recognize that from either side by noticing that you have a solved here, and that this edge is opposite, opposite. Solved, opposite, opposite. Opposite here, opposite here. And so from here, you can actually do a very fancy solution that's called dots canceling. It's the same move count from this cube state until solved as the E2M solution. However, it's MU exclusive. So, well, actually, it does have an AUF. You have to do a U2 if you can pre-recognize it. So you do a U2, and then you can swap this one to the bottom and this one to the bottom, and you'll notice that we have a 2 and 2 right here. Even before we insert ULUR edges, we have a 2x2 case. So we can do M prime, U2, M2, U2, M prime. Like that. However, if you're doing the E2M, which I find it's just... So I do E2M dots, that's kind of just why. So I would insert them, do it normally, and then E2M prime, E2M, or as I said, E2M, E2M prime. I don't really follow that M prime rule as well as I should. For this one, we have the eyes case, where there were dots but an M2 away, and it was all eyes. Like they made like an eye shape. You'll see. Yeah, the eye shape, or H, I guess. From here, I can recognize that because this is fully opposite, and then this is also fully opposite. So, opposite, opposite. That allows me to recognize it. You can also recognize it from the other side. It's the same thing. Same pattern. So you can do the canceling thing. U2, and then... But then you're going to have to do an M2 at the end, so it's actually less efficient. As opposed to just inserting them, AUFing correctly, and then E2M prime, E2M prime. Alright, now into misoriented centers. Now you can see why recognizing this from misoriented centers is so confusing. Luckily, I have devised a system that I use to recognize these in my solves. So with this one, I can instantly recognize that we have a swap here and a swap here, just because it looks like a dot on the M slice. Like, that's what the dot looks like on the M slice, except for we have these that are misaligned. So I just do a U2, M2, and then a U2, and then you just adjust the middle slice at the end there. This one I recognize exactly the same way. It is basically the same case from an M2 away, similar to the dot and the H case from last time. So, yep. With this one, and this one, however, I use a slightly different technique because I noticed that they're on the top and that I can cancel into solving them, sort of. So, normally I would just do an M, right, or an M prime, depending on how I would want to adjust it. But I have to pick which one. And I pick it based on whether the edges match or not. So if this edge matches, I try to match the edge. So this is blue and this is blue, so I match them up because that gives me this case, which is one move shorter than this case. Because this one you have to do an M2 at the end. See, for here, I notice that they're opposite, and so then I do an M prime. And then I can do the U2, M2, U2. And then with this, it's a dots case, and actually I can cancel part of the solution into the solve. So the way I do this is I recognize whether the edges need to go down or whether they need to go up. In this case, they need to go down, so I do E2, and then I move the edges down, and then I do another E2. And you see we didn't have to do the M prime at the end. Same thing goes here. This time the edges need to go up. So I do an E2, and then I do an M prime to bring them up, and then I do another E2. So that's basically how you do it. Recognizing should be pretty easy. You never have to really look at the sides unless you're doing the dots canceling thing that I talked about. Thanks for watching. See you in the next one.